Let's talk about statistical forecasting. Here's one I prepared earlier. So I might have already mentioned some of this, so you'll have to bear with. Kanban does encourage you to use real data, because real data means you can do real maths. I hate velocity, I'm sorry. I know some people in Scrum are really, really tight to velocity. Velocity is not a measure, it is not a metric. My old physics teacher used to tell me this: if you're confused about maths, look at the units and that will explain it all to you. Story points isn't a unit, it's a made-up thing, it's just a number. Velocity is a planning tool. It allows you to understand what you can bring into this sprint based on what you did in the last sprint. As soon as you start doing some sort of comparison or analysis on this, you're in mad. Even averaging your velocity doesn't really help you. It's trying to give you some sort of throughput rate. Actually, look at your delivery rate. Your delivery rate is really going to tell you what you need to do. And that's a real thing. Number of things you have done per day. That's a real thing. Sorry, you've had a question, sorry.
I think it depends how you use the story points. Story points can be ideal mandate as well. Which tend to be determined.
Oh, I'm sorry. I still need to talk to you afterwards about that. Ideal man days and story points have no place in the same sentence at all, ever. Story points are a completely different abstract way of measuring complexity and should only ever be treated that way. As soon as you mix in that, you're actually now doing man days, and then you need to read the mythical man month. But let me just say, instead of worrying about that, let go of it, release it, and come to the new world of real sums. I give you permission never to care about man days again. Measure real days. Man days are a measure of busyness. How busy are my people? I don't trust them. I want to know how busy they all are. Well, this slide deck's got the same problem. It's just happy to move on. So, lead time. How long does it take us to do a thing? Doesn't matter how big a thing is. How long does it take us to do, on average, a thing? That way, when we have another thing to do, we can talk about, well, it's going to take 11 days plus minus 2. What do you want done in the next 11 days? I can commit to 13 days and you're going to have the next thing. What do you want it to be? Meaningful conversation around real data. Throughput rate. You've got us to do, we need to do 50 things for you to be finished on your project. Well, we do one every other day on average. That gives you a coin toss 50% chance of knowing when things are gone. So that's if you're drawing a line through your cumulative flow chart on your delivery rate, you'll actually see, oh, well, the project finishes here. That is really a very dangerous situation to put yourself in, because you're now looking at the coin toss. 50% of projects will finish when that line's crossed. So you're betting your reputation / your career on a coin toss at that place. Please don't do that. That's an arithmetic mean. And arithmetic means are 50-50. They're not how the human brain works. The human brain actually works on medians. Let's talk about a better way. But at least that's better than talking about man days. It is a step in the right direction, but understand you need to have wide tolerances on anything you use there, because anything you use on just a 50-50 is, well, it's 50-50, right? Let's do things a better way. So, I don't want you to be limited to the short term. I want you to think about the long term. I'm really passionate about this. Even before I did Kanban, I was really passionate about predictability and thinking in Agile we're very woolly, and we can't afford to be, because people in businesses are not very woolly. They are very concrete. They listen with different ears. Estimation. Estimates are rubbish. Estimates are pointless. Estimates are at best, empirically, 60% accurate. That means you have a 40% variance on every of the very best estimates you will ever do. 40% variance. Unfortunately, your stakeholders have a 10% variance on what they're listening to, 15 at worst. You're talking 40% variance, they're talking 10 to 15% variance. Ask why our stakeholders aren't very pleased with us when we give them estimates. I mentioned Nokia earlier, I often do. Complexity, emergence. Every time we start writing a line of code, we're starting a voyage into the unknown. We have no idea of what the code base is going to do around that line of code, unless it is the very first line of code in a completely new build on something that's never going to touch another piece of software ever. Then you're going to have unknown effects. even if you wrote the rest of the code. So that means you're going to have emergence. That's where that 40% comes from. You're going to have not only your environment changing around you, but your requirements changing around you, and the things you're doing causing change around you. 40% variance based on emergence. So let's be a bit more scientific. The difference on a year-long project between plus or minus a month and plus or minus 5 months is what the difference between that 10%, 15% and 40% gives you. That, those are big numbers. We're doing a project, when's it going to be ready? January. Oh, it was ready February. That's okay. That's not so bad. We can live with that. It's going to be ready in January. It's ready in June. This project was about delivering the ski clothes. Probably no use to us now. And this is important. You might get lucky. Statistically, you'll only ever get lucky 6 times out of 10. You're going to be unlucky 4 times out of 10. So, be aware of it. If you're doing any recruiting, by the way, this is my top tip. If you've got a job and you get like 50 people applying and you don't want to read all those CVs, take 40 of them and put them in the bin. You've already eliminated all the unlucky candidates. You can't fault it. It works. Okay, there are after 100 odd people here. They're not going to put any CVs in bins, are they? Anyway, 6 times out of 10. So you need to be lucky if you're going to use estimation as any kind of planning technique. And luck shouldn't be there. Hope is not a strategy. That's a book I've never bought because I kind of thought the cover says it all for me. But, luck is not a strategy either. So, hashtag no estimates. Anyone seen any of that? Okay, a couple of you. Okay, so there is a risk to it. The risk is that we don't get, the value we get out of agile estimation is not the estimate. The estimate's pointless, wasted time, completely rubbish, and we spend 10% of our time doing it. Great, fantastic. The value we get out of estimation is that we all actually talk to each other. If I do planning poker with you and I say it's 3 points and you say it's 13, oh, that is the right slide, then there's a good chance I know something you don't, and a good chance you know something I don't, and there's a good chance none of the rest of the team knew those things, and now we're all going to talk about them while the whole team's there. We have shared tacit knowledge just before we start work on the thing. Yay! Big win. Estimate's pointless. Estimation has value. Kanban says make your policies explicit. If you've got a policy around sharing knowledge, have an explicit policy for it. Do it. Have a session to share knowledge. Do that thing. We're about to start a new story. Right, let's start a new story. First thing, let's share knowledge. Let's all share that. Or if you're going to do it hidden, do something valuable like BDD. Do the whole team writing Gherkin. At the end of it, you've got some Gherkin language which you can turn into a coded test. Or even if it's a manually coded test, at least you've got a condition of acceptance that everyone can understand. That's valuable. And you've got the shared tacit knowledge. Yay! No waste. We like no waste. That's called lean, reducing waste. Did I mention estimates are too inaccurate to be bothered to use as a long-term planning tool? So, we should talk about forecasts. I couldn't resist. Prince Charles. I think here in this country, we understand the word forecast better than anyone else in the world. An old Irish boss of mine once I was working at an American company, and we're on a conference call to San Francisco, and they said, what's the climate like over there anyway? He says, oh, we don't have a climate here, we just get lots of weather. They're kind of right, we do. And that's because we get the jet stream. And the jet stream makes our weather very unpredictable. But that's why when we get a weather forecast, we understand it, right? They say there's a chance of rain. That's shorthand for 20% or below. We might take a jacket, but it'll be a light one. We're not too worried. We're definitely going to have a strong rain tomorrow. Okay, that's 90% chance. It might not. There's still 10%. But I'm taking my coat and my brolly, and I'm going to use the tube. I'm not going to walk. We make these decisions based around the estimates. And actually, this is kind of interesting. They are a lot more right than they're wrong. But the human brain remembers the wrong ones. Kind of one of those weird foibles of the human brain. But if you talk to your estimates about a forecast rather than an estimate, they kind of get that. They're saying it's not a guess, right? That's good. It's not just an estimate, it's a forecast. We have science into this. It's got meaningful data that has helped derive this forecast, but it isn't guaranteed either. The whole Scrum.org movement away from the C word, don't have commitment in there. Use forecast, funnily enough. That's bizarre for Americans, but hey, Good on them. The C word was badly misunderstood. But the point is, it's not about saying, we promise. And the metaphor I use for that is, if the C word is used badly in Scrum, it is, we're going to deliver this lot in 2 weeks. By the way, I'm going to put the genitals of your choice on this anvil here and present you with a hammer. Should we not make our commitment, feel free to strike. That's kind of what the stakeholder hears by commitment quite a lot. It's not what we meant by it. It meant we're going to do our best and deal with the emergence that's going to come out of that. Forecast is, this is where we scientifically think things are going to come up based on our experience and based on our good knowledge. It's not a promise. It's the best we can do, and we can give you a likelihood around this forecast. I like the American forecasts where they talk about 20% chance precipitation. So they tell you how likely it is with a percentage number beside it rather than just code words. But that's useful. That means I can understand it a little bit. 20% chance of tornadoes. We should probably check the tornado shelters working. How do we do forecasting? Well, we hide the slides. Did I mention lead time and delivery rate are really, really important? Okay, so here's the secret. We didn't do the WIP section. These are related mathematically. Anyone heard of Little's Law? You two should have. There, one or two more. Okay. Little's Law links delivery rate, lead time, actually average delivery rate and average lead time with your average WIP. And if you've ever seen a cumulative flow diagram, if you look at the thing, you'll have a triangle. Your delivery rate is kind of as you're burning up. Your lead time is from there to there, and your WIP is from there to there. It's a triangle. A triangle on a graph represents a rule of A equals B over C, Little's Law. So, WIP is our primary control over these two things. And here's a top secret. The first thing you're going to do is you're going to reduce your lead time as you reduce your WIP. So I know we aren't doing that, but trust me on this. Oh God, I've done evangelism again. I've said trust me. It is true. The first thing that will happen is lead time will reduce. The shorter your lead time on a piece of work, the less effort it takes to finish that piece of work. That's not saying make the piece of work smaller. That is the same piece of work done over a shorter period of time. So you could take 2 weeks over it, and it'll take you more effort than if you took 1 week over it. Because you're going to have more. What did I do before Fred emailed me and I just read that thing about what's going on my eBay bid? Or what was I doing before lunch? Oh, Jim's off sick again. All of this waste happens. That leads to more rework. Rework, muda, waste, bad. Waste means more effort spent doing the same amount of work. There's a game I play with teams. If you ever want to get me in, I'll play it with you guys too. And it really shows, makes it visible how much waste we have when we actually do things concurrently, rather than focus on as few things as we possibly can at any given time. So, lead time shortens, then once that stabilizes, I should do a catalogue shot, shouldn't I? Once your lead time settles and stabilizes, which it will, it won't shorten forever, your delivery rate starts improving. That even sounds good, doesn't it? Your delivery rate starts improving. Yay! I don't think anybody in the world doesn't think that's a good idea. We want to deliver more faster. So limiting WIP will actually mean you can increase productivity with the same work, with the same team, working at the same level of capacity, if you like. Everyone will be fully loaded in both systems, but one way they're getting more work done than the other. Sounds mad that you wouldn't do it, right? Well, it is. You should do it, and I'll explain further another time, but not tonight. So first of all, I want you to understand sizing, which is going to come back to what you were talking about earlier. I'm quite glad we came this way now. Sizing. I don't know if this has ever happened. It says, great work on the schedule, Johnson. Now cut development time in half and we'll be in business. Or a company I worked at recently. The only team I trust to give me a decent estimate is yours, but that's too long. Can you half it, please? And they did. And they started the work on the project, knowing it would still take 3 years, but a year and a half meant they could start. Estimating and sizing are not the same things. Estimating is what you do at your sprint, well, actually you're grooming before you go to sprint planning, right? Because you don't do your planning poker at sprint planning, do you? Only you agilists out there. Oh, that's all right, everyone's still looking me in the eye. Wow. Okay, so that's what you do. You know, the planning broker, that's estimating. Before you get the story in to be allowed to be groomed, it has to be sized. You know, that's too big, it's an epic. Break it down. So I say dry stone walls. In dry stone walling, there's a rule. There's a pile of stones. You must take the stone from the top of the pile, pick it up, and put it in the wall. You don't go, oh, I need a stone about that size, let's have a rummage, because you're going to be rummaging all day. You don't pick up the stone and go, no, because you're going to be picking up and putting down stones all day. You pick up the stone and you use the stone. We don't, as teams, decide what work we're going to do. We get the backlog, that's the most important thing. The thing that's going to deliver the most value to the company, we'll do that one first. That's the stone we're going to do first. So what do we do with this pile of stones to make sure they're all usable? Well, every stone is unique, right? Some stones are big, some stones are small, some are round, some are pointy. Doesn't matter. Every stone is unique. Yes, great. But I can pick them all up. They're not boulders. I couldn't pick a boulder up. They're not pebbles. They'd fall out the wall. They're no use to me. They're stone-sized. It doesn't take long to say that's a stone-sized story. And you're sometimes going to get it wrong. Sometimes there's so much emergence in a thing that it turns into a tar pit. Or I remember one, again, Shelley, my UView experience, I remember we used to use sticky dots on our cards to represent a day of work. And we overlapped them so there were little crescents. And one of them, seriously, the sticky dots went right across the card. And I came in one morning and someone had drawn little feet on each of the dots and little antennae in the front. So we had very hungry caterpillars after that for the ones that went in. Well, it happens, but they happen infrequently, so they're not worth worrying about. The fact is, a stone is a stone. And as soon as you get into that situation, everything's 1 point. It's one work item. Imagine, if you will, you're in a scrum team and you have a velocity of 20 on average, 21, 19, whatever. So that means I can take in 1s, 2s, 3s, 5s, 8s and 13s. Yes? That's Fibonacci for us. However, I was taking this 13 and a 5 and we don't deliver anything. Happens a lot, that, on 13s. And so you have to have that sprint review where you stand up in front of the product owner and all the stakeholders say, sorry, we didn't finish anything this week. And then you carry it over and you still don't finish it. True story. It was fun, that one. That was a really fun sprint review. And then you finally finish it. And guess what? The team will never take a 13 in again. The right size, it seems, for a story coming into a scrum team is roughly a quarter of the size of the sprint, it seems. Or 5 points in that particular instance. Now, what I work out is actually most teams taking 3s, 5s and 8s if they're doing estimating. Great. That's 5 stories plus or minus 3. Now, can we all call them 1 and move on, please? Because they are all the same. Some are bigger, some are smaller. UView again, with 2,000 stories remaining. We did smalls, mediums and larges. We knew how many smalls we had, mediums we had and larges we had. And I was taught to come up with a prediction. With 2,000 stories left, I came up with a prediction. I keep emphasising this 2,000 stories because that's a lot of work left to do, right? And then showed them the next sheet on the spreadsheet and said if we forget about the smalls and larges and treat them all as mediums, it comes out as this. 2 days difference over 2,000 stories. Net result, next day we had small, medium, large and extra large. Just goes to show it's not always about being right, it's sometimes about the messaging. So I learned from that. I took their feedback and I don't present like that anymore. Don't give them surprises. Don't try and be right. Anyway, no, that's the point, is explain and bring them with you. Don't be combative with them and you'll find more success. So, if you're the idea of understanding a stone is a stone is a stone is a stone and everyone's unique and it doesn't matter, we don't need to put it in a bath and see how much water comes out and measure the volume. You don't need to measure the long side and the wide side and everything else. Everyone is going to be different at how big we think it is anyway. It's all going to have emergence. The best we can hope for is 60% accuracy. They're all 1. Move forward. And off we go. Average lead time per story, number of stories delivered per day. Throughput, measured in delivery rate, and lead time. And then you can have a meaningful conversation. So once you've got that data, and it's probably in one of your systems, whether it's Jira, TFS, Lean Kit, or something else, you can do some science. Let's step out of IT. Let's pretend you're running an ambulance service. You're already up and running. You know what your capacity is. You know what your demand is. Your lead times are a factor of your capacity and your demand, yes? How long does it take to get an ambulance to your place? Well, dead easy. So, we're going to have 1,000 new homes. What can we do? How do we deal with that situation? Well, we know each house has an average number of call-outs. We have that data. We have it historically. And we can apply that data to the 1,000 new homes based on the distance of those homes from the ambulance station and work out what the lead time will be if capacity doesn't change. And therefore, we can either change the capacity, put more ambulances there, more crews, add another ambulance station, change the hospitals we use, make all those kind of decisions based on real statistics. And this is what they do. This isn't magic or an example. This is what happens. I recently went to Disney World in Florida, and I loved it. I went all the major rides, and there's a little system you can use. The unofficial guide, I thoroughly recommend it, has a website called, it's called Lines. Oh, the app's called Lines. It's called Touring Guides. And what they worked out is if you apply some science, not only can they tell you how busy each individual Disney park will be on any given day in the next 12 months with a huge level of accuracy based on the statistical data they have from the years before, but they can work out a touring plan that will take you through all the major rides in that park and save you up to 4 hours queuing, and I'm not kidding, 4 hours in a single day queuing in the hot Florida sun. The longest wait time I had, and I went on the end of July, beginning of August this year, was 15 minutes. Talk to me later. Maths helps. Statistics helps. I wish I'd done it at school. I dropped it like a stone, and I wish I hadn't now. But this is, true. This is how you plan policing. This is how you plan your hospital allocation. All of these things. Every other industry in the world thinks this is normal, and we do estimates. Why? Not because our stakeholders asked for estimates. We've trained them to ask for estimates. We can do better. So, how do we do? We use the data, Luke. Any excuse, right? So, yeah, I've just explained all that, so I'll skip over Obi-Wan. Recognize this curve from earlier? It's called a variable distribution. You don't need to know that, because the maths can be done for you. However, this is what your lead times will look like. Remember I said you're going to get some big ones? These are your big ones. So if you have lead time coming out this way, frequency of that lead time occurring up there, you'll get a curve a bit like that. This is why we deal in medians, not means. We can then work out. So let's do some more maths examples. How am I going? I reckon I've got 10 more minutes, and do you want me to continue or stop and ask for questions? Because there's more to this, but I can get 10 minutes worth of value in, or you can ask questions. It's up to you. There's value in that too. That sounded terrible the way I introduced it. I'll keep going. This is a game show host called Monty Hall. Monty Hall used to run a game show called Let's Make a Deal in America. And there's a maths problem. It's quite famous, called the Monty Hall problem. Here's how it goes. You win the game. You're now offered the choice of 3 doors. Behind one door, there's the star prize, the car. Behind the other two doors, there's a goat. That's the booby prize. You don't even get the goat, but the goat tells you that it's a booby prize, right? So, what's the percentage chance you're going to pick the right door first time? 33%? Yeah, 1 in 3, 33%? Of course it is. You do have a 33% chance behind each door. Right, somebody pick a door number. 2. I heard 2. Right, so you tell Monty. So I'm Monty, I've got 1 and 3. They're mine. Now I'm going to tell you that behind door 3, oh, you see, I assumed this. Behind door 3 is a goat. So I'm throwing away door 3. It's gone. You're left with door 1 and door 2. I guarantee the car is behind either door 1 or door 2, and the goat is behind either door 1 or door 2. What's your percentage chance that it's behind door 2? 50-50? Everyone think?
33.
So this drives math students nuts. Most people think there's a car and there's a goat, and there's a door and there's a door. This guy at the front's trying to trick me, but it's obviously 50-50. I know a few of you are clever enough to say it's not. It isn't 50-50. Absolutely isn't. 67 to 33. Now, if you watch James May's Man Lab, you'll have seen an experiment done to prove this, which was quite funny. But it is 67 to 33. How can that be? That's mental, isn't it? How can the odds be like that? Well, here's a decision tree. Now, I'm going to have to change the rules and say you pick door 1 here to match my slides. It's horrible when audiences don't work with you, isn't it? So, on door 1, we had 33%, and then we had the other side, which had the combined door 2 and 3 at 67%. Then I came along and I took away door 3. I've added information to your system, basically, at this point. And that information was, actually, I've removed a goat. This could still be a goat. Who knows? The thing is, if you switch to door 2, or switch choices at this stage, you're twice as likely to win. During the whole time the show was running, something like 98% of people didn't switch. Obviously, you would, so you wouldn't. There's all sorts of NLP, you know, this is not the door you're looking for. You can do, but the point is, I don't care if you understand that or not. It really doesn't matter. All you need to know is that I know it and I'm right. And I've done the maths. And I've proved it. And as soon as you know that, if you're ever on a program and you're offered 3 doors, you're twice as likely to win if you change your door. You can use that simple rule now, and it doesn't matter if you understand it or not. This is the point with statistical forecasting. You don't have to be a maths guru to use this. You just have to understand that maths gurus have done this for you, and that it is a viable distribution, and it is quite complicated maths, but you can just apply it because it's right, and it will work. So here we go. Imagine you've done your stoning, your stone sizing. You've done 3 stories already, 3 stones, A, B, C. And they came out with the lead time of A was the shortest and B was the longest. Story D's come along. You haven't looked at it, you just know it's a stone because it's been stone sized for you. How likely is it to be between A and B in size, percentage-wise? The lines are a clue. There's no tricks here. Okay, 25% chance at each of those phases. Therefore, it's 50% chance it's between A and B. You're at coin toss. I know nothing about the story, my team's only done 3 stories before, and I already know the next story is 50% chance of being smaller than B and larger than A. And actually, it's 75% chance of being smaller than B in total, because who cares if it's smaller than my smallest, right? The magic of this means, in order to get to the point where this is a useful thing, rather than just a 50% is, you only need 11. If your team's done 11 stories, the 12th story is 90% likely, I've never looked at it, I've never estimated it, I just know it's stone sized, 90% likely between the smallest and the largest we've done already. After 11 stories. Maths is good, isn't it? We're liking this. Actually, here's the maths done for you. You can get better, but it's a logarithmic scale. So actually, to get more than 95% accuracy, you've got to do hundreds and hundreds of stories. And by then, you've gone through different team members, so less useful. Plus, you're talking about predicting the future. And if you can say, well, it's 99% likely. Is it really? Is it? You can have some emergence. Let's be realistic. 95% is pretty good. Let's not push the boat out here. So let's stick with that. And 95% is useful. That means you can keep a rolling average. Yeah? Because your team's changing, your context's changing, and you can get rid of those long ones that just occasionally happen. You know, 90% chance after 11 items. Then you plug in Monte Carlo modelling. Monte Carlo modelling is named after casino modelling, where you can do complex maths and analyse any casino game and see what the outcome is. All of the games are stacked against you apart from blackjack. If you do blackjack and play the correct move based on your hand and the dealer's hand and every single turn of the cards, you will win in the end. However, you'll be bored out of your brain and they'll work out what you're doing and they'll shut the table down because they'll know they'll lose. They don't like losing. They won't kick you out because you're not doing anything illegal. It's just boring and rubbish. So don't do it, but you could win in it. Every other game has been modelled. But this means you can actually model your system. And by the way, if you link it, I've actually started doing this. I'm really quite excited. I'm not paid by them and associated by them by any means, but I'm just kind of excited that they're doing it, so that you've got your system modeled in Neemkit already because you've been using it. Your data's already there because you've been using it, and now they're plugging in Monte Carlo modeling. So you can just click a few buttons, and based on that, you can say, well, I've got this project. It's roughly 100 work items big. We add one new work item every 5 we do, roughly, on this team. But it's always less than 1 in 20. We actually have a failure rate in there of 1 every 10. You can basically parameterize all these things based on actually what's happened in your system and what you predict might happen as you're getting better. Click a button, and it'll run your project 500 times. And then it'll make one of those graphs, the variable distribution, and it'll say, well, 95% of the project runs with random data finished before this date. You're 95% likely to finish the project in this date, based on the stats of how your team works. 75%, 50%, 20%. That curve, you remember? Just the volume of the curve. And then it'll start telling you how you move the curve left. And that's where it gets really interesting, because you can say, well, we're not starting this project till next year. What if we doubled our WIP? Now, I'm a Kanban guy. I told you to limit your WIP, and you should. The only way to increase your WIP is to actually increase your capability. So if you double your WIP in this QA area here, I have twice as many QA people, actually that's not going to be right in Moore's Law and all that, then you can bring in the date by 30 days. It'll target which areas you need to improve. If you improve your bug rate, if you improve your block rate, then you'll come in this much. And you can get real likelihoods based on this. And it's mathematical and scientific. And you can talk about those 10% and 15% variances that your stakeholders expect. Now, it isn't the only tool out there that does that. It's the only one I know of at the minute. However, the guy who knows a lot about this is not in this room right now. I know a bit about this, and I'm quite passionate about it. However, he is at a... if you let me just quickly skip back to my... I've lost my mouse. Is it over there? No wonder I can't see it. If you let me just skip into this presentation briefly. I'll come back to that slide. There's a conference happening in London on the 31st and 1st.